Hello dear friends, welcome to the channel. We have n to the fourth power plus 4 and we want to find for what conditions of n being an integer this expression can be equal to a prime number. Now my friends, let's try to factorize this. Adding and subtracting this 4n squared to our expression. You may have seen this. Adding and subtracting 4n squared, we will have two complete squares. This is n squared plus 2 all squared, and the second one is 2n all squared. So from the difference of two squares, we will write n squared minus 2n plus 2 and n squared plus 2n. Plus 2, and we want this be some prime number. Now my friends, a prime has only 1 and p as positive divisors, so one of these expressions, one of these factors should be equal to 1 or negative 1 maybe. Let's try to equaling this one to 1, my friends. Then we will have n squared minus 2n plus 2 is equal to 1. Having everything on the same side, we will have n squared minus 2n plus 1 is equal to 0. Then this is the complete square of n minus 1. So n should be equal to 1. Let's check if n is equal to 1. Let's check. N is equal to 1 becomes n to the fourth power plus 4, 1 to the fourth power plus 4, 1 plus 4 is equal to 5, and this is prime. So n is equal to 1 is an integer satisfying our conditions. Let's equal the second one to 1. Let's equal, let me write in white, n squared plus 2n plus 2 is equal to 1 gives similarly n squared plus 2n plus 1 is equal to 0. This is n plus 1 all squared, and n is equal to negative 1, also satisfying since we have fourth power. So plus minus 1 are our integers satisfying this equation. Let me try negative 1 for the first expression. N squared minus 2n plus 2 is equal to negative 1 becomes n squared minus 2n plus 3 is equal to 0. But this has no real solution since delta, the discriminant, is negative here. B squared minus 4 times 1 times c, 4 times a times c, becomes negative. So we have no real root here. And the second one will also give the same. N squared plus 2n plus 2 is equal to negative 1 gives n squared plus 2n plus 3 is equal to 0. Again, discriminant is negative, so no real root, no real solutions for this possibility. So the result, actually the set of solutions, is negative and positive 1 for n to make n to the fourth power plus 4 is equal to a prime number. Thank you for watching and see you in the next videos.